Welcome to this video, where we will dive deep into a very interesting problem. We have a situation where large base64 strings need to be decoded, ranging from a few hundred MB up to 5 GB each. The initial solution was to use the base64 decode function, but the decoding process was slower than expected when attempting to parallelize it using multiprocessing. Quite the conundrum, right? Now, let's talk about the solution provided. In a nutshell, the Python parallelism approach faced some hurdles. The global interpreter lock GIL in multi-threading restricted performance gains and interprocess communication inefficiencies plagued the multiprocessing attempts. Additionally, the memory-hungry nature of the operation combined with data copies further hindered the parallel implementations. The use of native CPython modules was proposed to circumvent these limitations and significantly improve computational speed. Continuing from there, the code shared showcases of fast and efficient parallel base64 decoding implementation written in C. By generating a conversion table for performance optimization, efficiently decoding characters, and leveraging OpenMP for parallel processing, the decoding process is expedited. The resulting solution outshines the previous Python implementations by a wide margin, proving the power of utilizing native modules for intensive operations. Building upon that, the provided setup.py script defines the necessary parameters to compile the C code into a Python module. By specifying the sources, compilation flags, and module details, the parallel_base64 module is created. This module encapsulates the optimized base64 decoding functionality, ready to be imported and utilized within Python for swift and efficient decoding tasks. Looking at the performance comparison results, the native CPython module's decoding time outshines previous implementations significantly. With a speed boost of 12.5 times using 8 cores, the parallel_base64 module that demonstrates the prowess of leveraging native modules for complex computational tasks. The optimization achieved through this approach highlights the efficiency and speed gained by incorporating C code for intensive operations. In conclusion, tackling the challenges of large-scale base64 decoding led us to explore the realms of Python parallelism and native module utilization. By understanding the limitations of Python's parallel processing, embracing C code integration, and optimizing the decoding operation, we've uncovered a path to enhance performance and computational efficiency. Remember, subscribe, like, and comment below. It's always a pleasure to hear from our viewers. Thank you for watching, and happy coding!